Now we take up different types of questions in which integration by parts is a useful tool. First type of such questions is integral e to the power of ax sine bx plus c dx or integral eax cos bx plus c dx. In such questions, integration by parts is a useful tool. Now, for solving these questions, we must keep in mind the following keywords. These words you must keep in your mind for solving such questions. Keywords are integrate twice by parts, integrate twice by parts and transpose. Integrate twice by parts and transpose. For solving such questions, you must keep these keywords in your mind. Then the questions will be easily solved. We try the following questions. First is e to the power of 2x cos 3x plus 4 dx. What we do is we regard this as first function and this as second function and integrate it. Let this integral be equal to I. Now this is first function and this is second function. So this will be equal to first function, that is e to x into integral of second. Integral of cos 3x plus 4 will be sine 3x plus 4 whole divided by 3, coefficient of x, minus integral of differentiation of first. Differentiation of e to the power of 2x is e to the power of 2x into 2 into integral of second. Integral of second is this. So this is sine 3x plus 4 whole divided by 3 dx. This is equal to e to the power of 2x sine 3x plus 4 whole divided by 3 minus 2 by 3 integral e to the power of 2x sine 3x plus 4 dx. 2 by 3 I have taken up. Now again regard this as first function and this as a second function. Keywords were integrate twice by parts and transpose. So once we have integrated, now we are integrating it again. So we will integrate twice and transpose. This will solve this question. So this is equal to e to the power of 2x sine 3x plus 4 whole divided by 3 minus 2 by 3 into first function e to x into integral of sine. Integration of sine is minus cos 3x plus 4 whole divided by 3. First function integral of second minus integral of differentiation of first. So differentiation of this. Differentiation of e to the power of 2x is e to the power of 2x into 2 into integral of second. Integration of second is this much. So this is minus cos 3x plus 4 by 3 whole into dx. And this is equal to e to the power of 2x sine 3x plus 4 whole divided by 3 minus. Now open this bracket. This will be minus minus plus. So plus 2 by 9 minus minus plus. This is 2 by 3 into 1 by 3. That is 2 by 9 e to the power of 2x cos 3x plus 4, and this will be minus minus plus and one more minus. So total sign will be minus. So this will be minus 2 by 3 into 2 by 3 is 4 by 9. Minus 4 by 9 integral e to the power of 2x cos of 3x plus 4 dx, and this is equal to e to the power of 2x sine 3x plus 4 by 3 plus 2 by 9 e to the power of 2x cos 3x plus 4 minus 4 by 9, and this is e to the power of 2x cos 3x plus 4, that is I, and this is I. Now take this to the side. What we get is I plus 4 by 9 I is equal to e to the power of 2x sine 3x plus 4 divided by 3 plus 2 by 9 e to the power of 2x cos 3x plus 4, and this is 9 plus 4, 13 by 9. So I will be equal to 9 by 13 of, this is 13 by 9. So take this to this side, this will be 9 by 13 e to the power of 2x sine 3x plus 4 whole divided by 3 plus 2 by 9 e to the power of 2x cos 3x plus 4 plus c, and this is equal to 1 by 39, that is e to the power of 2x sine 3x plus 4 divided by 13 3s are 39. So this will be 9 over 39, 9 over 39 plus, open this bracket, 9 9 cancels, we have 2 by 13. So this will be 2 by 13 e to the power of 2x cos 3x plus 4 plus c. So this is the answer. Now we take up the second part. Second part is integral cos log x dx. What we do is we put log x equal to t. So differential on log x is 1 by x, dx will be equal to dt, and from here we can write x is equal to e to the power of t. So dx will be equal to x dt, this is equal to et dt. So we can write this integral as, let this be equal to I. So I is equal to integral, now cos log x. So we will have cos log x is t, cos t into dx. dx is et dt. This is et dt. We can write this as e to the power of t cos t dt. Regard this as first function and this as second function. We will do integration by parts. So this will be equal to first function into integral of second. Integral of cos t is sin t minus integral of differentiation of first. Differentiation of et is et into integral of second. Integral of second is this. So we have sin t dt. Now this is in the form eax into cos bx plus c. So what we will do is integrate twice by parts and transpose. You can see the keywords on the side sheet. So this will be equal to, we have integrated it once, now we will again integrate. We will again integrate this and transpose. The question will be solved. So this will be et into sin t minus first function into integral of second. Integration of sine t is minus cos t minus integral of differentiation of first. Differentiation of et is et into integral of second. Integral of second is minus cos t dt. This is equal to et into sine t. Now open this bracket. This will be minus minus plus et cos t. This is minus minus plus and one more minus. So this will be minus integral et cos t dt. So what we get is this integral on right hand side. So we can write this as et sine t plus et cos t, and this is minus I. This is same as this et cos t, et cos t. Now transpose. Integrate twice by parts and transpose. Integrate once here and again at this time. Integrate twice by parts and transpose. So this will be 2I is equal to et sine t plus et cos t. Therefore I is equal to et is common, this is common, divided by 2 into sine t plus cos t plus c. Now we will replace t in terms of x. So what we do is, now t was log x, so we put t equal to log x in this. We have to express this in terms of the original variable, that is x. So x is equal to e to the power of t. So e to the power of t is x. So this will be x by 2 into sine of t. How much is t? T is log of x. Sine of log x plus cos of log x plus c. So this is the answer. We must convert this from t to x, the original variable in. Now you can try these questions on similar lines. In this, what we will do is we will change cos square x into 1 plus cos 2x by 2. 1 plus cos 2x by 2. Separate into 2. First will be a simple integral e to the power of 2x, and second can be done by integrating twice by parts and transpose. And in this question, what we will do is we will put log x equal to t and simplify. You can try these two yourself. We will give you the answers. Now another type of questions in which integration by parts is a useful tool is integral secant to the power of n theta d theta or integral cosecant n theta d theta. Case 1, when n is even. When the power of secant or cosecant is even, what we do is we put tangent theta equal to t, and if it is cosecant, we will put cotangent theta equal to t. This I have discussed earlier. Now second part is case 2, when n is odd. When n is odd, what we do is we will separate secant square theta. We will separate secant square theta from this and integrate the result by parts. We will separate secant square theta and integrate the result by parts. That is, we will write I is equal to secant to the power of n minus 2 theta into secant square theta. Regard this as first function, this as second function, and integrate by parts. Separate secant square theta, integrate by parts, and in the result replace tangent square theta by secant square theta minus 1. We will again get I on the right hand side. By doing this procedure, we will again get I on the right hand side. Transpose this I to the left hand side, the power of secant theta will get reduced by 2. Repeat the process if required. If the power is say 5, then by doing this procedure, the power will become 3. 3 is again odd. We will repeat the procedure once more. The power will again reduce by 2. So now the power will be, instead of secant cube theta, it will reduce to secant theta. From 5 to 3, from 3 to 1. And the question will be solved. Because we know the integration of secant theta. And similarly in this case, if n is odd, we will separate cosecant square theta and integrate by parts. Separate cosecant square theta and integrate by parts. Replace cotangent square theta by cosecant square theta minus 1 and transpose I, which we get on right hand side, to the left hand side. The power of cosecant will get reduced by 2. It will become n minus 2. If power is 5, it will become 3. And repeat the process, the power will reduce from 3 to 1. So this is the general method. Separate secant square theta and integrate by parts. In the result, transpose I from right hand side to the left hand side and we will get the result. Now I will take 2 examples. First is cosecant cube theta d theta. Cosecant cube theta d theta. Now this is an odd power, so what we will do is we will write this as cosecant theta into cosecant square theta d theta. Regard this as first function and this as second function and integrate by parts. What we get is we will get first function, that is cosecant theta, into integration of second. Integration of cosecant square theta is minus cotangent theta, because differential of cotangent theta is minus cosecant square theta. So integration of cosecant square theta will be minus cotangent theta minus integral of differentiation of first. Now differentiation of cosecant theta is minus cosecant theta cotangent theta into integration of second. Integration of second is same as this. This is minus cotangent theta d theta. This is equal to minus cosecant theta cotangent theta. This will be minus minus plus and one more minus. So net result will be a negative sign. So this will be minus cosecant theta cotangent square theta d theta. Now in the result we will replace cotangent square theta with cosecant square theta minus 1. So we write this as minus cosecant theta cotangent theta minus integral of cosecant theta into cotangent square theta can be written as cosecant square theta minus 1 using square formula. So this is equal to minus cosecant theta cotangent theta minus integral of cosecant cube theta. This will be cosecant cube theta d theta, and this will be minus minus plus plus integral cosecant theta d theta, and this is equal to minus cosecant theta cotangent theta minus I plus integral of cosecant theta. Integration of cosecant theta is log cosecant theta minus cotangent theta. Now transpose this I to the left hand side. This is I. So we get 2I is equal to minus cosecant theta cotangent theta plus log of cosecant theta minus cotangent theta. And this implies I is equal to minus half cosecant theta cotangent theta plus 1 by 2 log cosecant theta minus cotangent theta plus constant of integration. I is equal to integral secant to the power of phi theta d theta. Now what we do is we will separate two powers of secant theta from this. What we get is secant cube theta secant square theta d theta. Separate two powers of secant theta and integrate by parts. Now we will integrate this by parts. So first function into integral of secant square theta is tangent theta minus integral of differentiation of differentiation of secant cube theta is 3 secant 3 minus 1 is 2 theta into differentiation of inner function, that is differentiation of secant theta. Differentiation of secant theta is secant theta tangent theta. So we get secant theta tangent theta. So minus integral of differentiation of this 3 secant square theta into differentiation of inner function is secant theta tangent theta into integral of second function. Integration of secant square theta is tangent theta d theta, and this is equal to secant cube theta tangent theta minus 3 is common, integral of this will be secant cube theta into tangent square theta. Now replace tangent square theta by secant square theta minus 1. Separate this into 2 and take I from right hand side to left hand side. So this is equal to secant cube theta tangent theta minus 3 into integral secant cube theta into tangent square theta. Tangent square theta can be written as secant square theta minus 1 using square formula. So this is equal to secant cube theta tangent theta minus 3 into integral of secant to the power of 5 theta d theta minus minus plus 3 integral secant cube theta d theta. Now we write this as secant cube theta tangent theta minus 3i plus, regard this function as I1, 3i1, and this implies 4i is equal to secant cube theta tangent theta plus 3i1, and from here we get I is equal to 1 by 4 secant cube theta tangent theta plus 3 by 4 I, or call this as where I1 is equal to integral secant cube theta d theta. We will evaluate secant cube theta separately using the same process. What we do is we will separate two powers of secant cube theta. Now secant cube theta d theta is equal to secant theta, separate two powers of secant theta, that is secant square theta d theta, and integrate by parts. This is equal to first function into integral of second. Integral of secant square theta is tangent theta minus integral of differentiation of first. Differentiation of secant theta is secant theta tangent theta into integration of second. Integration of secant square theta is tangent theta d theta. This is equal to secant theta tangent theta minus integral of secant theta tan square theta. And here we will replace tangent square by secant square theta minus 1. So what we do is, you can see the side sheet. Secant theta tangent theta minus integral of secant theta into tangent square theta is secant square theta minus 1 d theta. And this is equal to secant theta tangent theta minus integral of secant cube theta d theta minus minus plus integral of secant theta d theta. And this is equal to secant theta tangent theta minus I1 plus integral of secant theta. Integration of secant theta is log secant theta plus tangent theta. Log secant theta plus tangent theta. Therefore, 2I1 is equal to, take this to the left hand side. 2I1 is secant theta tangent theta plus log of secant theta plus tangent theta. And this implies I1 is equal to 1 by 2 secant theta tangent theta plus 1 by 2 log of secant theta plus tangent theta. So integration of secant cube theta is this much. Now substitute this in 1. So 1 implies I is equal to 1 by 4 secant cube theta tangent theta plus 3 by 4 I1. 3 by 4 of this. So this will be 3 by 4. 3 by 8 secant theta tangent theta plus 3 by 8 log secant theta plus tangent theta plus constant of integration. So this is the answer. This is the answer. You can try these questions on similar lines. We are providing the answers.